Hey folks, Cool18 here, and welcome to another, well, I was going to say Unity 3D tutorial, but this is mostly a Blender tutorial. I got a question on Facebook from John asking about how I got these sorts of structures. What technique did I use to make these ramps in my pinball game that I demoed relatively recently on one of my channels. So I've got, it's a pinball game, it's relatively standard, and let's see if I can actually pull off a shot to the ramp. No, of course not. Oh, how embarrassing, I can't play my own game. I'll give it one more try and then we'll see. But I can get, theoretically, there we go, I can get the ball up onto the ramp. So he asked, wait, how exactly did you construct these ramps? What's the technique that you used to do that? So I'm actually going to, just as an example, I'm going to pop into another table that I'm working on here that is still under heavy development. And again, you can see these sorts of paths. Well, the one on the right-hand side doesn't go anywhere yet, just sort of a placeholder. But I've got these paths, and they're constructed out of meshes. And exactly how did I make this? Well, I made it in Blender. So let's go, and I'm going to click the table, click Select. There's my actual model that I have for this in Blender. And if we zoom out and go to wireframe mode, because wireframe mode is just so useful, you can see that I've got my structures here. Well, I am using actually a couple of different techniques to get this sort of thing going. If I'm in edit mode. There we go, select this. So I've got this curve here. If I go in and tab in, and I fiddle around with this curve, you can see that my model is quite dynamic and easily editable in Blender here. I can change the height. I can make my ramps go up and down very, very, very easily. This is done using a technique called, using the array modifier, but then there's another one that I use over here for these wire ramps, because I can take this wire ramp and sort of deform it as well, relatively easily. And this is using a bevel option on the curve. So we're going to talk about exactly what the hell this all means, what curves are in Blender, and how you can use them to sort of generate this kind of geometry. So let's start with a new file, and certainly not save my changes here. So I've got a new file just set to blank. The only thing I got to do is turn on my screencast keys so that you guys can see exactly what I'm clicking at any given time. I'm going to try to keep the pacing up as usual, and so if you miss something, feel free to pause, rewind, do all that. So let's talk about curves to start off with. If we go Shift A and go into the curve panel, there's actually two basic types of curves that we can work with this. There's the Bezier versions, which come as a sort of open-ended curve or a circle, or the NURBS version, which again comes as an open-ended curve or a circle. Now, these curves are just zero thickness lines. So let me just grab a quick example with the Bezier. I'll just fiddle around a little bit, and then we're going to talk about what's actually going on. So I've got this line. If I go into edit mode and I grab one of these control points, I can move it around and reshape it quite easily. With one selected, I can hit E to extrude and keep the line going. I can use these handles to twist the line without moving it to change how it goes in and out. I can even make very sharp corners. If I click on one of these nodes and I hit V, I can change the handle type to free, and then I can actually, now they're no longer aligned with each other, so I can make these very sharp corners. And doesn't that look really cool and sexy? Now, by itself, this cannot be imported into Unity, or rather, it will import into Unity, but again, this line has no thickness, it has no body, so it won't do anything in Unity. It won't render, it won't be useful. I mean, there may be things you can do, I don't know, let's not get into too many advanced things, but generally speaking, this is not particularly useful. What you need to do is add some amount of volume to it. So that's a curve by itself. This is a Bezier curve, or Bezier curve, and it's defined by having these various nodes or control points that have these handles, and you can use the handles to determine exactly how the curve comes out. Let's delete this one. Let's go back to the simple 2-point control node. So again, I've added it in. I hit tab to go into edit mode. And what kind of things can I do? So you can see what we have is we have a line that starts at this point and ends at this point. Now, what these nodes do is simply control how the line enters and leaves these points. That's all the handles influence. So if I take this and I move it all the way down, this line is coming out directly to the right, and so you end up with something that's relatively straightish. If I move it all the way up to the top, the line comes out of this point heading straight up and then slowly fades to head towards the next line, influenced by its own control point. If I take this control point and I stretch it out vertically, you can see the line will stick to this handle longer and longer and longer, and if I bring it down, it'll turn away quite quickly, to the point where if I bring it right on top of the control node, it basically turns instantly, and again, we've got kind of a straight line situation. And the line on the other side will also affect that sort of slope quite a bit. So you end up with a lot of control. By default, these handles are aligned. I can click on a control node and hit V again and hit move to free, and then I can move them each independently, and that lets you make your sharp corners. I can put it back to aligned, and then they will again, move in tandem. I always go back to the control node before hitting V, because if you have a handle selected and you hit V and you go to free, it changes this one line. You can see it turns to red instead of pink. Red means it's free alignment. But the thing is, if the other side is still in alignment mode, even though this one is free to move, the other side just moves with it. And actually, I can't even turn this other one. It doesn't make any sense. Usually you don't work in that mode. Usually you want them both free or both in alignment. So the short way of doing that is just to have the node itself selected, and then you can break them up like that. And again, you can have one node selected. You can extrude from it. It'll make a copy of the handle configuration, but then you can move them independently, like so. You can take one of the nodes. You can hit X and delete that one node, eliminating that. If you have a couple of them selected, you can hit W and get the subdivide button, and that will split it in half. And in fact, we can change the number of cuts over here. So now we've subdivided this one segment in 3, and it does its best to keep the curve going exactly where it was. So it tries to place these control points in sensible locations to make it keep going in the same direction that it was going in. But then, of course, we can still modify it as much as we want. You can, I believe if you have 2 nodes selected and you hit X, I think we can delete a segment, which will actually get rid of the line connection between those two altogether. So now we almost have 2 independent curves in the same object. With 2 nodes selected, you can hit F to reconnect them. And we can do that with our 2 end nodes as well. And now we sort of have a circle-ish. And that's really the only difference between the curve Bezier and the curve circle. The circle is a Bezier curve that just happens to be linked. And it so happens that it starts off in a perfect configuration to make a very nice and sexy circle. But we could, stretch it out like that, get an oval. We could can I not rotate this one? Well, that's weird. Oh, what mode do they start in? Are they in vector? Ah, that's what's going on. So yeah, I don't usually play around with the vector control node type. I mostly just bounce between aligned and free, and that seems to do pretty much everything that I'm hoping to do. So there, we've got some sort of weird deformed bean kind of object. So that's the Bezier version. The NURBS version is interesting. It basically follows all the same rules. The difference is in the control nodes, they work quite differently, and I find that this might be a little hard to explain with just these 4 control points, but if I grab this and extrude and extrude and extrude, just so we've got a little bit more. Now, if I grab one of these nodes and move it around, you can see the curve tries to follow this sort of polygon line that we're drawing out. So if I zigzag this way, the curve will sort of zigzag smoothly. You don't really get the sharp corners the same way. There's different handle. I don't think these actually do anything in this mode. So the NURBS curves are actually very nice to work with. They're much less fiddly because there's just less things to kind of click on. They're always going to be smooth and sexy and nice. But it also means you've got a little bit less control and a little bit less options if you're trying to do something very specific. You can still do things like we can still merge these 2 sections together. It's kind of weird that it doesn't actually show them as connected. We can, should be able to delete that segment. In fact, I do. We can delete individual nodes here, same as always, and we can subdivide as well with the W key. And we can make as many segments as we want. Like so. Now, you'll notice that both these curves, when we work on them, it's got all these arrows. This is basically the resolution of things. If we go to the curve panel and scroll down to here, resolution, I can turn this down. It'll be really obvious what's going on in this mode. You'll see the number of arrows go away. And if I tab out, and if we keep going down and down and down, you'll see that there's going to reach a point where the curve becomes quite chunky. And in fact, these are almost just straight lines between points. Same thing if we go to this curve here, we can do the same thing. Wait. Am I dreaming? Well, there's the preview resolution here. I was sure that the same thing existed on this. Okay, it does there. Why doesn't it over here? That's very bizarre. I'm actually confused. Oh, there we are. There, now I have an active spline. Maybe I needed things selected? Maybe this one was weird because I think we broke it at some point, so there was 2 splines in there. I bet you that's what was causing this kind of weirdness. But anyway, we've got a resolution thing again. You can see as I bring it down, it starts to become sharper and chunkier. And if I bring it up, it becomes smoother and smoother and smoother. This will have implications later on because, again, Unity can't use these curves by themselves because they don't have any thickness, any structure. There's nothing to render. But we can use them in some fashion, and this kind of resolution will tie into how many polygons get created in our shape. So there we go. So that's the basics of working with the curves themselves. And again, we can do this. I've been working just sort of flat, but you can also grab these in the sort of Z-axis and bring them up and, you know, make roller coasters, right? You can totally do that. In fact, this would be a great system for making roller coasters. So how do we give this thing body? How do we give it structure? So there's 2 different techniques for doing it. There is the array modifier technique, and then there is the bevel technique. And we're going to start by talking about the bevel technique. So let's use some of these shapes that I've already got on here. So we've got our kind of a roller coastery loopy kind of thing, and then we've got this kind of beanie kind of shape. And let's rename this to the let's call this bean, and let's call this roller coaster. All right. So let's say I want to give. Actually, let's start with something really simple. Let's say I just want this to be a wire. I want this to be round. So let's start off by adding another curve. We're going to add a normal circle curve. Let me take this and move it down here. I'm going to take this and actually shrink it down quite a bit. We'll talk about exactly why I'm doing that later on. There's another good example of why the resolution really ties in, because you can see there's a lot of arrows here. In fact, they're overlapping quite a bit. If I bring it all the way down, it'll be a square. Then we get various polygon shapes and so on and so forth. Right? Clear, clear? So let's take this one. So it's not too many shapes going on, so we won't kill our computer as we do this next step. So I'm going to take the roller coaster, and I'm going to say I would like to sweep this circle shape along the entire wire here and see what that would look like. So the way you would use that is this bevel tool, and I didn't figure it out for a long time because to me bevel doesn't scream out sort of extruding or sweeping a shape, but that's what it means in this context. You can add bevel objects. I'm going to click on this. I'm going to find my Bezier circle, and now you can see my circle here has been swept all along my shape. And I can take this circle and I can edit it, and I could shrink it down, maybe shrink it down this way, and you can see, especially if I move it a little closer, let's put it in the middle over here. If I go back into edit mode, I can shrink. There we are. I can grow and have direct control over things. I can also start to modify the shape. Let's say I take this point and stick it out this way, then shrink. There we are. So now I'm going to have that sort of oddball shape kind of stick out. Especially, let's make an actual point. Let me zoom in way over here. Let's take this, let's change this to free, and then take them and point them inwards, like so. So now I've got a sharp point, and you can see, theoretically, yeah. If we go into wireframe mode, there you go. It should make it pretty obvious. We've got the sharp point over here, like that sort of teardrop shape, but it's swept along the entire form of the structure. Yeah, in fact, let's stay in wireframe mode because I think it explains things quite a bit more. You can also see, again, where this U resolution really comes into play, because it chooses how many times that happens, and of course has major impact over how many faces are created here between the shapes. So if you're using this for a video game, you probably want a relatively low resolution on these. It still looks pretty damn smooth because of course smooth shading and various things. So you want to use as few polygons as possible to get what you're looking for. So we can sweep that anyway, and it works with both the NURBS curves and the Bezier. So here we've got a Bezier sort of path and a Bezier outline or profile. Let's switch this around. Let's swap this for that NURBS curve. Whoa, which is way too big. So let's go into here, take this whole thing, scale it way down. You know what? Good enough. And you can see I've got that weird sort of zigzaggy thing going on. Because this is an open curve, it will be like a flat two-dimensional shape, right? It's got no actual thickness around these edges. So depending on what you're trying to do, you often don't want to do that. You want to have something that sort of closes in on itself. Like with my ramps, let's go ahead and pop back here and open this. I'll show you the profile that I'm using for my ramps is, oh, it's this bit right here, right? So you can see I've got it kind of enclosed. This is not actually a curve. This is a mesh. We're going to talk about that technique later on. But you can see it's totally enclosed all the way around. So that gives it a proper sense of thickness, right? Because it's a physical material. I don't have the ends capped, so you can see through there. But other than that, it gives it that kind of thickness. And then if we look at the ramps themselves in practice, it looks and feels, you know, kind of right. Okay. So, I still have this open here, so all my crazy squiggles. So yeah, you can switch from Bezier to NURBS back and forth. They both work perfectly fine with one another. So again, this works really well if, this also works great with perfectly straight lines. So let's use the bean and then go into the bean and shrink it down, shrink it down, shrink it down, shrink it down. So this will work perfectly fine with open stuff. So you end up with tubes, right? Like that. There is also a button on here to fill caps. So instead of a tube, now we've got filled in caps on both sides. You might wonder what this taper object is. This allows you to use another object to determine the thickness. Let's put the NURBS curve in there. And then let's go in here and start, it's actually a bad example because the shape is kind of dumb and silly. Hang on, let me take all this. Let me scale it in the Y to 0. Scale Y 0. There you go. Again, when I'm recording, sometimes it eats some of my keybinds. And then let's take this and move it in the Y down. Right? You see how it's tapering the one end? So that's what the taper does. Now, it tapers uniformly in every axis. I'm kind of annoyed by that. I would like it if I could take it and move it in the Z and just control the tapering in the Z-axis, but it doesn't work that way. It's in this top view. It's all along the Y-axis all the time. That's what controls the taper, like that. So if I go below the origin of this particular shape, then it'll taper in the negative direction and grow, right? But now we can make a sort of, I don't know, a worm or a slug or something. And that's fine. So this technique works great if you've got this one uniform outline, right? This is an outline that gets swept all along the way. And again, all your outlines, you should draw all your outlines in this sort of top-down view. The outlines should all be flat on the surface for this to work. And then your actual curve, once you've got this thing, let's take this, let's subdivide it, right? And this thing can go in any direction you want. That's totally fine. It can go up, and whoa, that's really extreme. You know, it can go up and that's okay. Your path can go in any directions. Your outlines have to be flat. Otherwise, you get really weird problems. Also, another way to generate some really weird problems. So I can take this and I can move it in object mode all that I want. That's totally fine. If I go into the edit mode and I take this and I start to move, then it's kind of weird because the sweeping of the object is based on the origin. Generally speaking, you want your shape to be centered around its origin. If you do end up editing it and grabbing things and moving it in a way that's kind of weird, and then you're like, oh, that's not what I want, what can I do? You can always reset the origin in some fashion, which, well, you can type origin, but yeah, Shift Control Alt C. I mean, it's a huge keybind, but I actually tend to use it quite frequently, so it's one of the few I have memorized. If we set it to the origin to the center of mass, there we go, and that'll generally kind of fix your problems and get everything usually the way you kind of want to work it. So, all right, that's technique number 1. Technique number 2 is to use arrays. Let's clear the world and try this again. So, using arrays, why would you want to use that when this technique works quite well? Well, there's a couple of different reasons. One, you saw that we could add an end cap to our tube, right? But here, I've got something completely different going on. Let's go into edit mode. You can see that my curves here, while it works the same way as I've described, I can drag these around. They've got ends that are different. The ends follow, right? I've got this wider sort of scoop at the entrance, and I've got this kind of like hole thing at the end for the ball to drop out of. And they follow the curve, but if you look really carefully, this is the end of my curve right here. So this actually gets stuck on to the end of things. And over here, this is the end of my curve right here. And then an extra bit gets stuck on to the front. And they are not uniform, they change. So that's one thing you cannot do with the beveling of the curves. The other thing is the curves have to just be a silhouette, right? They were just that profile, that two-dimensional profile. And you can see an example of it here with my wire. My wire, if I go to the curve thing, is using an object called wire radius for the bevel, and that's this little guy right over here. If I take this and is that not? That is the wrong thing. What do I want? Wire radius. Where's the wire radius? Oh, it's over there. If I go into edit mode for this and I grab this and I scale it up, you can see this is my control for my wire radius. It's this little circle here. So it's perfectly uniform all the way through. I may or may not have end caps on. I think I probably just have them off because I don't need end caps. They're sinking into the table, right? So I'll never actually... Something really weird going on with the rendering here. Things are being inverted. Let's not freak out about it. So they touch the table, so I'm never actually going to see that. So that technique is fine. Here, it's all uniform all the way through. It's just the wire. So the array mechanic or technique we're about to talk lets you do these different end caps. The other thing they do is they actually repeat one shape over and over. So my array that I use for these ramps is actually a repeating of this shape here over and over and over again. And you can see it's got thickness. It's not just a profile. And if I go into it and I do something crazy, let's put a split in this way. And then let's take one of these points and just drag it out in the X. So now I've got this sort of pointy structure, and I tab out. You can see my ramps now have this repeating structure like that stick out. And this is something you can't do with the beveling of the curves because it's just a flat profile that just gets swept along. This is an actual repeating of an object over and over, so any detail I put in there is fine. If you want to make a racing game where you've got roads, you can make one segment of road, you can get it all set up with your like a railing, maybe a tree, and then you just array it so that you get that repeating thing. You get the rail all the way, you get a tree at regular intervals or whatever the hell you're looking for. So that you can do with the array modifier. So let's go and talk about how that works. Again, your basic path can be either a Bezier curve or a NURBS curve. We'll use a Bezier here because why not? And yeah, let's leave that in for now. Next, we need the shape, and the shape is going to be a mesh. This is going to be, well, theoretically you could use any kind of base shape, but for this we're going to use a mesh because that's usually what I'm going to use this array technique for. So let's start off with a cube, because this is actually what I use as the base for my ramp anyway. Let me just move it over here in move mode, and then I'm going to go into edit mode, and what am I going to do? I guess I can sort of duplicate my pinball ramp here. So I'm going to grab what is basically my top. Again, we're in top-down view. I'm looking down on this, but I still have to imagine that this Y direction is actually going to be my top. So I'm going to, I'm going to turn on the turn off the limit selection to visible mode. So that way when I sweep this, it's going to grab everything from the box properly in the Y direction. I'm going to bring it down to around here. Then what I'm going to do is, actually, I'm going to split this in half. I'm going to get rid of the left-hand side, and I'm going to add a mirror modifier, just so that I'm guaranteed to work symmetrically. It makes my life way easier. Then I'm going to grab stuff out of this side. I'm going to extrude it, yeah, just ever so slightly. Normally I'd be measuring this, but what the hell. And then I'm going to extrude it upwards by a certain amount. So now I've got this kind of brackety kind of shape, and this is going to be the basis of my my ramp, right? It's a very, very simple shape. So I want to define this curve. Let's go into the curve, and we are going to mostly just make it bigger, so we've got some actual geometry to see, proportionally to that. Let's put in a subdivision, grab that, and just sort of bring it over to here. Okay, so now we've got a decent sized curve, and what we want to do is we want to sweep this to the curve. Well, previously we'd be working on the curve and doing something to it. Now we're actually going to go the other way around. We're going to start with this shape here, and we're going to add some modifiers. Before I do, though, just because this is actually a great technique, I'm going to move this over to here. I'm going to create a duplicate of this. That way I'm going to keep this kind of master copy. Now, normally you create a duplicate with Shift D, and this creates an actual double object, and then I can go into this object and I could, make a change to it, tab out, and that's it. They're both independent objects. Well, I don't want that in this case. Instead of Shift D, I'm going to use Alt D, and this will create a linked copy. And what does that mean? If I go into this and I make a change, it makes a change to both. They are duplicates, or they are linked copies of one another. So making a change to one will change the other. Anything I do in object mode is fine. I can scale, I can rotate in object mode. Any of those things are fine. But if I make any changes in edit mode, that's where it gets propagated out. So again, I'm going to use, whoops, not Alt-A. I'm going to use Alt-D. Move it over here. So now I've got this linked copy. So this is what I'm going to use as my basis to follow the ramp. That way I've always got this extra copy kicking around that's easy to work with, so I can make changes to it. I don't need to do this, but you'll see why it's handy in a little bit. Let's just move on. So I'm going to go into the modifier on my cube right now. And it's got the mirror modifier. That's great. We're going to add another modifier called array. So array is interesting. It lets you make an array of objects, right? So by default, this is where we mix it around down here. The fit type is fixed count. I can create, so right now it's 2, 3, 4, 5, a bunch of those. Well, that's not the direction I want. I want it to go kind of upwards. Well, look down here to relative offset. I can do constant offset or relative offset. If I go to constant, then I can actually put in a specific number of coordinates to space things out. This is actual like unit numbers, right? So this would be 1.56 units is the offset every time. This is rarely very helpful, I find. Much more handy is the relative offset. At 1, it's exactly equal to the width of one of these. If I go into wireframe mode, you can see they fit very nicely. If I went to 1.1, then they would have a nice little gap. And if I, again, I'm going to move over to my original here. If I take this and just sort of shrink it, ooh, that's going to be weird. If I take this and move it in the X to be thinner and then tab out, you can see that this array is still using that size to instruct the positioning. So, all right, so the count is good, the offset is good, except, well, that's not the direction I want to offset. I don't want to offset side by side. Well, I don't want to go in the X. Let's set the X to 0 and the Y to 1. Oh, the Y is not what we want either. I always get my coordinate systems mixed up. We want it in the Z. There we go. Now that's looking... Now we've got something going on. So I can make this sort of a ramp tube pipey thing as long or as short as I want. All right, well, so we've got to start. What's next? Well, first of all, it just goes out like a skyscraper. Great technique for building skyscrapers, but not what we're looking for. We want it to follow this curve. So we're going to add yet another modifier. This one is going to be called the curve deform modifier. So we're going to scroll down the stack. So this is the third one. I guess I could shrink these, I think, by minimizing. So that's the mirror component, which I can, turn on and off. This is the array component. I can turn the visualization on and off, and then the curve. And all it needs is a curve to follow. So, well, we've got a Bezier curve going on. Boom. I'm going to hit that, and all right, so it's glued to the curve, but not looking quite right. What about a different axis? Y is not it. Z. Oh, now Z's kind of interesting here. Let's go to the array. Let's add the number of counts. Okay, it's clearly following the curve, but not quite right. First of all, this fixed count thing, this is nonsense. We don't want to work with this. We don't want to guess as to what the length should be. Luckily, there's a different fit type available. We can fit to a curve. This is the length of the array is going to be fitted to a curve. So let's set it to the Bezier curve there. Now, it's theoretically fitting the length of the curve, but it doesn't look right. Why is that? Well, let me show you something. If I'm in object mode here. If I go into G and I start moving my object around, what is going on? Why is it so bizarre? The origin points of these objects that you're going to be fitting to a curve matter very, very, very much. So what you want to do, and there's a couple of different ways you could probably work it, but here's what I do. G is to move objects, right? G moves an object. Well, Alt-G will reset the position of an object. This will just set it back to the origin. You can see that the origin of this object is in the center of the grid. Again, if I move it, you can see the little orange origin point gets moved around. And I guess I can move it to here. And again, Alt-G, it just puts the origin back to the middle. And if I hit Tab here, or actually if I turn off all these modifiers, right, the curve, the array, you can see the object is properly exactly in the middle of the screen. And that's exactly what we're looking for. We'll turn the array back on. We'll turn the curve back on. Now it's working. Now I believe the curve itself also needs to be positioned in the middle because it's the position of the two objects. If I take the curve and I move it away, then again, weird things start to happen because it's not in the middle. I'm going to Alt-G, put it back in the middle. Both the curve and the object have their origin points set to the middle of the screen. Well, what if I don't want the object to be here? I still want to modify where it looks. Well, you don't move the curve. Instead, you have the curve selected, you go into edit mode, and then from there I can grab everything and move it around, and it works exactly the way that you want. Or you can grab a single control point and start to manipulate that. Now you can see that it's always going to use whole numbers of my little segment here. It's going to try its best to fit them all in, but that's why you get the sort of chunkiness. As it becomes slightly too long, it takes one away, or as it becomes slightly too short, it adds one. So it's not super precise as opposed to the previous way where we were beveling a curve profile. Then it would always be exactly the same length. Now you can get more precision by making your shape shorter. Right, so again, top view is this profile, if I go into edit mode over here, but if I go to the front, I could take my shape and make it shorter. And then tab out, and then what I have is considerably more precision. The endpoint is going to be really accurate based on where my curve endpoint is there, because my individual segments are shorter. It also means I could potentially get smoother curves out of it, because it kind of breaks things up more and more into smaller components. But of course, the downside to that is going to be more triangles to render. And certainly in the physics mode, it also means much more complex mesh colliders as well. So there's a pro and con to having things be of different sizes. If you had this component, have this component be quite long, and let's go to the front view, let's grab these, let's strictly in the Z direction, tab out, quite long, then you've got very few triangles involved. But your precision goes way, way down, both in terms of the smoothness of the curves and also the fitting your endpoints exactly right. Okay? Hopefully that is totally clear to everyone. If it's not, well, I'll give you your money back. So, so we've got this. I find this is a pretty nice length for this. Again, we could do this to quickly put out roads, do different things. And again, because these objects are linked, again, if I take this, I can go into here, and this is my object that's actually controlling the curve. But I find it inconvenient to work in this mode, right? You can see your results right away. That's kind of convenient. But by having a linked version over here, it's usually easier to work with this sort of original form of your object. A couple of modifiers that are quite handy here in the, well, first of all, in the mirror modifier, the clipping can be handy when you're editing, because I don't know if you noticed when I was in here, but there was one really weird situation where I could take the bottom and sort of split it up and put it back together and do weird things like that. If I turn on clipping, then these middle vertices will stay stuck together. Usually that's what you want when you're working in the mirror mode. And merge is also very important. When those two get close to each other in the middle, these 2 points get close to each other in the middle, which they will always stay together because of clipping. And also if I sort of merge them together this way, or if I clip together this way, then again, they will sort of form up. Merge will force those vertices to actually blend into one, and so it simplifies your model a little bit. Well, over here, in your array, there's also a merge button available, and that will be with these two segments when they meet up together. Right over here, there's vertices. If you click merge, they will actually merge together into one point, which again goes a long way towards simplifying your model and keeping the information shorter. It's usually good. You don't necessarily want it, but it's there. So there's a few other things, but we won't talk about some of those options. You can read them in the manual. These are the key ones here. Now, so this is great for repeating shapes. How do we do those fancy end cappy things? Well, let's take our model over here. I'm going to do a Shift D to duplicate it. This is not going to be a linked duplicate. I'm just going to use this as the basis for an end cap. So let's go and edit this. So again, let's just take this, stretch it out. I'm going to make it look a lot like my ramp entrance. And then I'm going to stretch it out to the X direction. So there we go. We've got a sort of a flared out ramp entrance bit. I'm actually going to rename this cube 2 to entrance. Entrance. Okay, just so I know what's what. And let's rename this one to ramp profile or ramp segment or whatever the heck you want to call it. Anything there would be fine. And what I would just do is rename this one to ramp. There, that's my actual ramp. Or you could do something like ramp 1, and this would be ramp1.curve. So I know what's what. Again, the curve itself will not render in Unity, and so it'll get imported, but it's fine. All right, and of course this is not unique to Unity. You can use this to export models for whatever the hell you want. So in our array modifier, we've got the start cap and end cap option. So I'm going to use the start cap, I'm going to use the entrance, and check it out. It just sticks the entrance bit onto the front. So now I can take this curve and move it around, and it keeps this perfectly stuck on. If you get anything weird where it's not lining up properly, there's a couple of different reasons for that. Usually it means your origins aren't the same. Like I duplicated this, and so now the center point, the origin, is right in the middle here. Well, here, you can see I could line these up, right? So that if I line it up so that their top bits are exactly lined up, you can see that their origin points are also lined up, right? The little orange dot in the middle, they line up perfectly because that's what the array uses to figure things out. If I move over here and I edit this shape and I just take this shape and I move it up, grab and move directly up like this, right? The shape is exactly the same shape as before, but relative to the origin point, it has changed. Alternatively, if I undo this and do something like I can just select this point at the top, and then I can do something like cursor, snap cursor to selected, so I move my 3D cursor to the selected, get out of edit mode, and now I can do my Control-Alt-Shift, set cursor origin to 3D cursor. Either way is exactly the same. Now the origin relative to the geometry is in a different position, right? It's very visible from, this view here. Right, so the origin point is more or less in the middle of this block. Well, here the origin point is here. And even if I had the origin point, if I took the origin point and set it to the center of the mask. Whoa. Oh, that's my mirror modifier kind of mangling things up. But even if, if the origin point was relatively centered, like about here, it still wouldn't kind of mesh up with these sorts of bits. So what does this imply? Well, now if I look, it's not connected properly. You see that? Then that's the problem. So your origin points have to match up. So what do you do if you sort of mess things up like this? Because there's no way I could take this shape and kind of eyeball it to be like, okay, I can take it and move it up. Come on. There we go. Move it up, and that's roughly right? And then you go back and you look, you're like, whoops. You're like, oh no, that's not quite right. Now they're overlapping. God, how am I ever going to get them to line up properly? Well, easy. What we do is grab one vertex. Now let's take a look at what I'm doing. I'm grabbing this one at the end that's sort of on the inside, right? This would be the outside one, and this is the inside one. So now I'm going to say snap cursor to selected. I'm going to tab out, and I'm going to say origin to 3D cursor on this shape. Then I'm going to go over to this shape, and I'm going to do the same thing. I'm going to select this place here, snap cursor to selected, tab out, origin to 3D cursor. Now, they're basically using the same vertice as their origin. So now if I go back to my ramp, there, now things are repeating properly. Now, does it matter which one you use? Sort of, kind of. You can see here, there we go. If I'm in edit mode, you can see my endpoint is here. Well, it's got this whole other segment going on, and why is that? Well, because it's repeating based on that topmost point. So it's sort of, this is the topmost point, and then the other bit sticking out. And if I look at the other end, again, this is my end point, and if I move this slightly to get another segment, right, it's offset just a little weird, which is fine, but if that sort of thing is bothering you, it means that in practice with our shape, we actually want to use this bottom vertex here as our common point. But then it sort of has implications for this shape, because actually what we'd want to do is, it's like, I guess what we'll do is use Control M to mirror along the Z-axis, right? And then put the origin point down here. It's not worth the trouble. I've probably just lost you guys, and I apologize for that, but that's why that sort of thing goes. But as long as, you've got the same sort of relative origin on your two shapes, which is what we have here, that's very topmost vertice on both, then it's going to line up and everything will be peachy keen. Obviously, if you do something like start deforming stuff up here, then you're going to have a really hard time getting things to line up properly because of the match. That's why I always start with the one shape and then just tweak that shape more or less carefully. And I try not to change this connecting bit, right? I leave this connecting bit exactly untouched, and then I start working later on. Even if I did want to do something kind of extreme, then I would do it, here or something like that. That way I still have this bit that's exactly the same, that will match up perfectly over here, which means that all of my bits will merge together properly. Now, if you did want to do some extra modification to the shape after the fact, one thing I would do is I could take this shape. Actually, hold on, let me undo that because it looks stupid. Thank you. I can take this shape, select it, I can duplicate it, Again, it's going to follow all the same rules of kind of weirdness based on position. Let me undo the position change, right? Actually, that undid the duplication. So I'm going to duplicate it. I'm going to hit escape. So now I've got 2 copies of ramp 1 in the same place. Well, one copy of it, let's say I want to be able to make changes. I want to work on texture mapping or something. This sort of structure is not good for texture mapping. It's fine if it's a repeating texture, because then what you do is you do your UV mapping based on this object here, which is linked to your actual ramp. So if you've got a repeating shape, you know, like if this is supposed to be a road and you want your dashed lines, your yellow dashed lines for your lanes in the middle, then you would texture this and it would repeat beautifully along the shape. But if you want something that's different, you know, you want some, I don't know, I can't think of something to describe that you would want to paint on this ramp specifically, and you want, you know, you don't want it to be repeating on every segment. You want it to work differently, which means you need to do UV mapping based on the whole ramp. Well, you can't UV map this structure as is. But if we go down and we apply these changes, we'll apply the curve. No, we want to start from the top. I don't know if it matters. Let me think here. Yeah, I think it does matter. Probably won't let us do this. Oh, it does, but it's stupid. So undo. Start from the top. Do the mirror modifier first, so you apply that mirror modifier. So now if I go into edit mode with this, you can see it's no longer, I can edit both sides independently. So it applied what it was there. I'm going to do the same thing with the array. I'm going to apply the array. So if I go into edit mode, now it's one giant shape that I can edit individually. And then I will apply the curve. So now if I edit it, I've got my shape that is actually following the curve. So I can do, you know, a very specific thing. Like I've decided that, oh, there should be a missing wall over here, right? I want to get rid of this particular segment there. It's going to look a little weird because they're overlapping one another, but now because it's not following the curve, I can also take this and move it aside, you know, and that it will work fine. Or more accurately, I can take my ramp that's based on these curves and I can hit M and just shove it on a different layer so I don't see it anymore, right? So now I've got 2 layers. I've got this one here, which is my curve with all the modifiers put on. And I've got this layer over here, which is just my mesh that I can modify. And then I can look and see, oh yeah, there it is. There's that missing wall segment I put in. When you import this into Blender, what Blender basically does is does an FBX import, into Unity. It basically does an FBX export from the Blender file automatically for you. So you can do that yourself. You can go and export as an Autodesk FBX, which is the format that's being used. And then you can get just this one mesh put in there. And what it does, even these curves, like this guy here, that doesn't really exist as a mesh. It's just this modifier tree. Well, when you export it to an FBX, either manually through here or automatically by bringing it into Unity, what it does is it applies all these modifiers. So in Unity, if I were to bring this file in, and again, the example is quite clear when I look at my roller derby table, I don't have any of these converted into meshes at this point because I'm not at the phase of modeling yet. When I save this and tab back into Unity, I'm not saving it because I don't want the spiky version. But in Unity, this is just brought down to a kind of a mesh level. And you can see in my list here, I've got a few extra things, including some random curves and Bezier curves and things like that. Well, this one is badly named. It's not actually a curve. But this ramp curve, number 1, is actually the curve that describes the shape of this guy here. I've got it disabled. Not that it really matters because it doesn't render. But because of that, I just disable it so that it's not going to affect my game overhead. It's not going to slow things down in any way whatsoever. But so that's that. One other little caveat here. I don't know if it's really visible in this example. I applied a transparent material to these curves to make it look like they're plastic. And actually, you can see here, like the transparency. Well, I'm not sure if it's really. If this were really wiggly. Let's see. Let me close this without saving. Let me go back over here. Let me open my table again. We're going to see if I can show you an example that works. This is outside of what I was planning for the tutorial, but why not? Just because there's a gotcha if you try to do transparent stuff like I'm doing. So we're going to edit this curve. I'm going to take this and subdivide it a bunch of times. Then I'm going to take this, bring it down here. This is something you do quite often in pinball, actually, is that you have these sort of like zigzaggy segments to basically slow down the ball a little as it goes down the there we go, these ramps. Okay, so let's save this, go back into Blender, The problem is Blender does not sort, or Unity rather, does not sort the triangles based on distance. So what you can get with these transparencies is sometimes they'll draw in the wrong order, and you'll get really weird kind of artifacts going on, where it doesn't transparency properly, and it will look stupid and dumb. I can't seem to fake it here, but it was definitely a problem with my other table. Yeah, that's fine. It was a problem earlier with my other table with just these little wobbly bits like this. And so what I had to do to get around it, and you can see if I go in and I click and I click, I've actually broken them up into segments, especially around these horseshoe pins. So what I did is I made my one curve, got it positioned to the point where I was very happy with it, made a duplicate, and in the duplicate I applied all of the modifiers, and then I went in and edited the mesh and just broke the mesh. I just grabbed all of these faces and I hit P to split them off from the object. So I created a sub-object and then another sub-object and another one there, and that was just to resolve certain transparency issues, for example. So that's the only gotcha if you're doing weird transparent stuff like I am. But this tool is really, really powerful for a lot of stuff. You can quickly make little rope models. I mean, ropes that aren't supposed to move, right? Like if you've got a coil of rope just piled up on the floor, well then in Blender you would just do that with curves, right? You just do a curve that sort of spirals up and up and up and up, and then give it a kind of radius, same thing that I did with the wire here. Do that, and then you can, do some texture mapping or something. In fact, you might not want to do this radius here. You actually probably would want to use a mesh segment, just like we did with the ramp, just a cylinder of a certain size, and then you could UV map that cylinder to look like it's got the one rope texture that's coiled around, and then just repeat that throughout your whole spiral, and then you get a nice little rope object sitting around in a corner. Also, really good for roads, paths that need a little bit of structure to them, and it's a cool little technique. Again, this is mostly for static stuff, right? And it's very easy to modify here. So I can tab in Blender and modify this. What if you want to do the same sort of thing in Unity? Dynamically move these shapes around. Well, that's a whole other tutorial. That's going to be bones. You're going to want to sort of create your general shape to start off with. Like this, if this was supposed to be a snake enemy, you could create the sort of basic snake shape. In fact, you might want to do it like this, where it's straight. And then what you're going to want to do is use bones and then animate the bones either as a pre-made animations in Blender, just the sort of slithering back and forth motion for the movement, or you could programmatically change the bones in Unity based on whatever various crazy inputs you're trying to do. But we'll look at more advanced animations and bones and things in a later tutorial one day, I promise. See you next time, folks. Bye-bye.